Now let's see what a complete schedule is. A schedule is said to be complete if the last operation of each transaction is either abort or commit. So what is the meaning of it is, till now we didn't see what is abort and what is commit. I'll just explain you. Now whenever a transaction is saying that the last statement is commit, and if you are going to execute that statement, it means that whatever writes it has done till now, they have to be made permanent, right? So whenever you do write, see, whenever you read, you are going to read from database, and whenever you write, you are going to write to the database, and in the meanwhile the copy is going to be in your temporary memory. Whenever you write, the copy is going to propagate to the hard disk or the database, which means the write is going to be propagated into the database, but still you are supposed to say commit. Now whenever you say commit, it means that don't allow anyone to change it. That is the meaning of it, right? Or you want this change to be permanent, right? So no other transaction should come and undo this the changes made by this transaction. With examples it will be clear, right? It might be a bit confusing here. So when you have already written what is the use of commit, right? With examples I'll tell you what is the meaning of it. So for now you can understand that whenever I say commit, it means that whatever changes are done till now, they have to be permanent and we are not supposed to change them, okay, later. So it is not possible that you can undo the changes. And let's say this abort means, so whenever any transaction does abort, it means that whatever changes are made by this, you just undo them, right? For example, it has done write operation, you just undo it and set a value to previous value before it has done this, which means before when it has started reading a, whatever value it was, you are going to put it there, right? Now the problem here is, this is going to create a problem. So by the time you are trying to restore the value, someone else has already committed the value of a, then you cannot do this. So anyway, that is not what we are trying to explain here. Here I just want to tell you that whatever the type of schedule it is, if all the transactions are showing you either commit or abort at the end, we call such a schedule as complete schedule. Now is this possible or not, is it right or wrong, don't worry about it as of now, okay? That is not the intention of our explanation here. Here we are just concerned whether it is complete or not, okay? Now come here. Now we can see, based on the placement of this commit and based on the placement of the abort, we can say that some are recoverable and some are unrecoverable schedules. Now let's say this recoverable schedule. Recoverable schedule means, I'll show you what is happening here. Let us say T1 is trying to transfer some amount from A to B, right? Assume that T1 is trying to do this. It is trying to transfer from A to B some 50 rupees, and initially A value is 100. This is what is A value, right? And T2, it is trying to increase the A by 4%, right? So which means T2 is trying to make A equal to A plus 4% of A. This is what T2 is trying. Return back the value, which means T1 has started the transaction and read the value of A. Minus 50, which means the value of A is 50 now, and then it is going to write back this value into the database. Now what will be the value present in the database? It will be 50, right? And now from the database, T2 is trying to read it. So T2 will read 50 instead of 100, got it? And now it is going to increment it by 4%, which means it made it to 52, right? And then it incremented means here it is going to be 52, A's value is going to be 52, and it is going to write the value of A to the database, which means in the database its value is now 52. Earlier it was 50, now it is made 52. Initially it was 100, then it is made 50, now it is made 52, and now it is saying commit. Commit means whatever changes I made, I want them to be permanently available there, and please don't undo whatever I made, right? So what is that this transaction T2 has done is incremented the value of A by 4%, right? Now that change we don't want to undo it. Therefore, this value of 52 has to be there permanently, or whatever changes are made by T2 should be always reflected there somehow. Now, what is happening if T1 is, after executing for some time, it has decided that it has to roll back, right? Because of some reason it is failing, right? Either maybe you can assume that there is a hard disk failure, or some hardware failure, or some power failure. Because of some failure, you are trying to you are not able to complete it, and so according to the atomicity rule, you are going to roll it back, right? So when you roll it back, what you are trying to do is, what is this transaction trying to do is, it is going to reset whatever it has done, whatever modifications it has done, it is going to undo them. Now it will think that I made the value of A from 100 to 50, so let me write 100, right? So that is what it wants to do, but then it has already committed, right? And so what happens is, whatever it has done, if you allow this this action, then whatever action is performed by T2, that will be gone. Commit means it is saying that all my actions should be permanently reflecting in the database, but by doing the rollback here, all the actions done by this one are lost, right? Therefore, this is not recoverable. Got it? So such a problem, such a schedule is called as unrecoverable problem schedule, right? Okay, now how to solve this problem is, why did this happen is, you can think of this in another way. Let us say it is an exam, and there is a person here writing, and someone has copied from him, right? So let us say two people are cheating in an exam, and someone has written some answer and someone else has copied it, right? And now, before this person has submitted his answer paper to the examiner, this person has submitted the answer paper to the examiner and he left. Now after he left, this person changed the answer, right? He thought that, okay, this answer was not right, so let me change it, right? Now what happens, this person is going to submit the answer paper after this person has already left. Now he is going to lose the marks. Got it? Now how to make sure that this person will not lose the marks in this case? So one simple way is, if you have copied from other person, then don't submit your answer paper until this other person has submitted the answer paper, right? In case if the other person has submitted the answer paper, changed his answer, then you are supposed to change the answer, right? Just an analogy, right? So in this case, if you want to see what happens in commit is, whenever you are going to read a data which is not committed, it is not committed, isn't it? Whenever you are going to read the data which is not committed, then you don't commit until the other person has committed, right? In case if the other person is rolling back, then you too roll back, then only you are going to have consistency, right? Now look at this. The problem, how to solve this problem is, now this person has written the value and this person is reading that value from him. This person has written some value and this person is reading the value from him, right? Now when he is going to write it, this answer is going to be right, provided that these changes are going to be there in the database. If these changes are not going to be there, then your increase of 4% would have been done on this. Got it? So you just wait until the other person commits. So whenever you are doing this dirty read, you don't commit until the other person commits, which means this commit has to be ordered, right? So when you are performing dirty read, just wait for the other one to commit, then only you commit. In this case, if the other one is not going to commit, let us say other one is going to say that I want to roll back, I want to undo whatever changes I did, right? Then you will have a chance that you too can roll it back. Got it? That is called as cascading rollback. If you have that chance, then it is called as recoverable. Here you don't have that chance. You are already done and it is over, right? Now you cannot roll back. But here you have a chance that whenever it rolled back, you too can roll back, and then you can undo, and again later at some later point in time you can start again, right? Without any effect on the consistency. Got it? So if a transaction has to be recoverable, then in case of any dirty read, don't commit unless the other fellow has committed, other transaction has committed. If you can follow that rule, it is going to be recoverable. Otherwise, it is unrecoverable. Okay, fine.